The water we use today has been on Earth for millions of years.
All right, so the water we use today, so I'll do the first example with you. So that's the very first line. So the water we use today has been on the Earth for millions of years. When it says a cycle, that water is just cycling. So we're not getting new water. It's the same that's been here for thousands and thousands and thousands of years. It's just cycling. So it's been in different places and it's been in different parts of the cycle, but it just keeps going. It's that continuous movement. So once you finish one line, go ahead, start looking at the second line to see what's coming up. Next, ancient sea life.
Ancient sea life lived in it. Dinosaurs drank it. And you use it to wash up in the morning.
All right, so that water that you're drinking, at some point, that's the same water a long, long time ago that the dinosaurs were drinking.
What? So we are drinking. So we're gonna turn into T-Rexes? If Spider-Man got bit, then
Water is recycled on Earth by the water cycle.
Okay, so just like you recycle hopefully you're recycling at home your cans and your plastic and all your things that can be recycled so that it can be used again. That's the same process with the water cycle. We're using that water again.
Let's see how the water cycle works. The sun's heat causes water to evaporate from water bodies, such as oceans, lakes, rivers, and streams.
Make sure you get that part.
The water vapor rises high in the air. High up in the atmosphere, the water vapor cools and condenses on tiny dust particles.
So you know how we talked about yesterday about how, like when you're in the car, sometimes when you get in the car and you can kind of put your finger down through the water, like you can see the water vapor that's condensed on the glass, and you can kind of run your finger over the window and feel the wetness. Or sometimes in the morning you can feel the wetness like it out on the grass. Or if you've had a drink and it starts getting more, it's it looks like it's leaking everywhere. That's condensation. So that same stuff is happening just like it does on the glass of your car and on your cup and on the plants. That same thing is happening in the sky, and where it's collecting is on those dust particles.
Many tiny droplets of water gather together and form a cloud.
He's fine.
What happens when such clouds form? When the water droplets become heavy enough, they fall to Earth's surface in the form of rain, sleet, snow, or hail.
So rain, sleet, snow, or hail is how it's falling. Okay.
No, isn't something like slush? Slush is milk. A piece to see. What sauce is
All right, so that depends on the temperature,
Process is called precipitation.
and that's called the bottom of it, precipitation.
This precipitation falls on land or back into bodies of water.
Right, so that's where we were talking about where some of it's going and the infiltration going down into entering Earth's on land, the soil. And that percolation is that if it continues to move, so the roots and all the plants are going to soak up some of that water. Some of it might stay and get evaporated by the sun's heat. And then that percolation, if it keeps going, percolation is that movement through. If it continues,
A part of the precipitation infiltrates into the groundwater.
All right, so here it is. Again, some of it went through here back into the water sources. That's that runoff. Here, infiltrate, like think of these as, it's infiltrating the earth, the soil here, and it's going through. And this groundwater, it's water in the ground. And notice how because of these gaps with these rocks that are in here, notice how it kind of just goes through those cracks. And when you have bigger areas, like look over here, this one, there's a bigger gap, and some of these have more spaces between them, more water can collect there versus like look at the soil here, not as much water is collecting, like you don't have as many gaps. If you remember back to last year when we talked about different types of soils and how their particle sizes, some of them have bigger gaps in between the particles. Like when we talked about clay, anybody remember about their particle size? Hold on, I just asked a question. Do you remember what you learned about clay last year?
We talked about.
Did it have really large particle size or really small?
Really small.
Yeah, they're really small. So remember when listen, I had the ones that were in class do it with me. We got together and I said, okay, you're pretend like you're a particle. And if I say clay, like we got really close together. And then when we were something like sand, or something that has a larger particle size, we had to get farther apart because there were more gaps in between. So depending on the size, that's depending on how much water is able to be absorbed, or how much is and retained, or how much is going through and draining through.
The water we use today has water. When the water droplets, a part of the precipitation infiltrates into the groundwater. Some of this groundwater is absorbed by plants.
All right, so we're on the second page.
Yeah. 1 second, wait.
So some of it's going to be absorbed by the plants. They need. Huh? It's with the A's. at the top.
I see it. And
All right.
for some reason, we already used it.
Roots absorb the water. Then it travels up through the stem and reaches the other parts of the plant.
All right, so you may see water hitting a leaf, like when it's raining, but that's not where the water is entering through. It's entering through the roots and then moving up through the stem to eventually get to the leaves and the other parts.
Some of the water is released by the leaves back into the atmosphere. This process is called transpiration.
All right, so there's our new vocabulary that we talked about, transpiration. So think of it like plant sweat. The plants are giving off and releasing it back into the atmosphere for it to continue just like it does in the ocean. That water vapor will rise and cool and condense, and then we're starting all over again.
Transpiration, like evaporation, turns liquid water into water vapor.
So you know how I said evaporation, we're going from a liquid to a gas. Condensation, we're going from a gas to a liquid. You need to know that transpiration is going from a liquid to a gas as well, just like evaporation in the oceans.
What happens to this water vapor? Under the right conditions, this water vapor rises and condenses to form clouds, and the whole cycle begins again.
So even though like all of this is happening, it's not just happening. Like when you see a model of the cycle, it always looks like it's going from evaporation to condensation to precipitation. Like it looks like this big round wheel. But in reality, that is happening all over. Like it's multiple cycles going on. So some of, like if you think about droplets of water, some droplets of water may be in the evaporation phase of it. Others may be in the condensation. Others may be doing runoff. Others may be stuck underground. So eventually it may feed into an ocean, but it may sit underground for quite some time.
Like a million years.
Yeah. So, ladies, so this cycle, that little going around, think of that just, I mean, thousands of that happening at the same time. Okay. So we can have different cycles happening in different places. It could be raining in Austin, and dry as can be here. So lots of cycles going on simultaneously.
Let us review what we just learned. The water cycle involves the processes of evaporation, transpiration, condensation, precipitation, and infiltration.